So we talked about stating hypotheses, computing a test statistic, and then based on the value, we're going to state conclusions. Haven't quite looked at the details, but we'll look at what the conclusions look like. So there's two possible things you might say at the conclusion of a hypothesis test. Here they are, depending on what you see. The first one is, hey, I think something's happening. Results are considered statistically significant, and we reject the null hypothesis. So that means to say that what I was looking for seems to be there, that there's been a change in the parameter value from the usual value. The null hypothesis does not seem to be in place anymore. There's been a change, and the change has happened in the direction I was looking for. Number two says results are not statistically significant, and we fail to reject the null hypothesis. So that means either we didn't see the change we wanted, or we didn't see a big enough change at all to think something is happening. And in that case, we say we fail to reject. So the two things that we do, reject the null, fail to reject the null. That's the primary response to looking at the value of a test statistic and then drawing a conclusion. It's one of those two conclusions, reject or fail to reject. The notion of statistical significance is important. Statistical significance means the results would be unlikely due to chance alone, or unlikely to be due to chance alone, or write it any way you want, would be unlikely to happen due to chance alone. Maybe that's a better way to say it. Likely to happen due to chance alone. In which case, you state the results are statistically significant, you reject the null hypothesis, and you're going to go ahead and accept the alternative. Say, that's what's happening. The alternative seems to be what's in place. The mean, the proportion, or whatever is either larger or smaller than I thought it was, or maybe not equal to what I thought it was. So that's statistical significance. So no statistical significance means the results could be due to chance alone. So could more or less easily be due to chance alone. You would see them rather frequently due to chance alone. Over here, unlikely. Unlikely usually means unlikely. For us means 5% chance or less, ordinarily. Likely due to chance alone would be more than 5% chance. We'll state the results not considered statistically significant, and we fail to reject the null hypothesis. That's how it works. So we have to kind of figure out which one of these things is happening based on the value of the test statistic. That'll be our task in the future. We're not quite there yet, but we can look at some examples of null and alternative hypotheses. No hypotheses I put here. Okay. You think 10-pound bags of potatoes are underfilled. So you would say, as my null hypothesis, is the mean weight of 10-pound bags is 10 pounds. And as your alternative, you say, my concern is I think it's less than 10. Okay. You think a medication is effective at lowering blood pressure from 145. So I guess we'll be checking the blood pressure of people after they take the medication. The null hypothesis is the mean is 145. It did not change. The alternative is the mean went down after medication. The overall long-term mean for people who had high blood pressure goes down if they take the medication. You think over 6% of cell phones are defective. The null hypothesis might be that P is 0.06, and the alternative you're trying to discover is P exceeds 0.06. So ordinarily when you're running these tests, it's because a claim has been made that the failure rate is some number. Here the failure rate maybe was 6%, and from your experience it looks like it's more, so you're going to do a test of whether the P has remained at 6% or whether it's now exceeded 6%. You think the reported value of 23% of college, that 23% of college, that 23% of college students smoke pot has changed. 23%. So that's a proportion. So the null hypothesis would be the proportion ordinarily would be 0.23, or has been in the past, or we think it might be now. And HA is no, it's not. It's different. College students aren't the same as they were. Maybe they're smoking more pot, maybe they're smoking less pot, but they've changed their perspective on pot. Maybe we think that legalizing pot might reduce the number of students that smoke pot, or maybe legalizing pot might increase the proportion. Let's see if there's been a change. And then we can try to analyze why the change happened and what kind of change it was, if there was a change. And if there's no change, then I guess there's nothing to analyze. We'll just go, oh well, it seems like it's the same way it used to be. So that is the conclusion stating part of hypothesis testing. And we're closing in on this thing called p-value. It's going to come up shortly. We're not there yet, but we're getting there.